on with solving equations. Now we're going to get the variable on both sides of the equal sign and talk about how we solve from there. So I got three main steps to follow when I solve just equations in general. My first one, you have to do this every single time, simplify each side of the equation, each side of the equal sign. So simplify everything you possibly can before you start trying to solve anything. And I'll show you an example of that here shortly. Next thing is we want to get the variable, to whichever variable you're looking for, to one side of the equation, to get to one side of the equal sign. And then after we get that variable to one side of the equal sign, we can then get it by itself, right? We always do the inverse of what's being done. So those are the three steps. Always simplify each side first, get the variable to one side, and then get it by itself. If you follow those every single time, hey, you shouldn't go wrong unless you make a little mistake by going too fast. So let's look at number one here. So simplify each side. I look at the left side, already simplified, can't do anything. Look at the right side of the equal sign, already simplified, good to go. Now we want to get the variable to one side. Well, I can either move this 3w over here, or I can move the 7w over here. I like to keep my variable positive. So remember, if I'm going to move one over, I'm either adding or subtracting it, depending on if it's positive or negative. So I'm going to move my 3w to the right side, because I'm going to keep my w positive, and I'll show you how that works. So to get rid of a 3w on the left side, I have to subtract it, right? The inverse of a positive 3w would be a negative 3w. Those will cancel each other. Whatever I do to one side, I got to do it to the other side of the equal sign. And then let's go ahead and work through that. So 3w minus 3w gets rid of it. That's how I move it. I bring down my 2. I bring down my equal sign. And 7w minus 3w is 4w. Okay, that's why I moved the 3w instead of the 7w, because then I would have ended up with a negative w if I'd have done the other one. I know it gets kind of wordy, kind of confusing there, but hopefully that made sense to you. So here, now it's just like it was before. Get that variable by itself. So the inverse of multiplying by 4 with the w is dividing by 4. Whatever I do to one side, I do to the other. 4's cancel. Bring my w down, bring my equal sign down. 2 divided by 4. Well, preferably keep this as a fraction. And 2 over 4, I could just simplify that into 1/2. If I took it on a calculator, I get 0.5 as well. But usually, if we can keep it as a fraction, let's keep it as a fraction. So w equals 1/2. Looking over at number 2. Same thing. Left side is simplified. Right side is simplified. So now let's get our variable to one side. Well, if I move the 5a, I would subtract 5a, right? Well, if I did that, I get a negative a over here, don't I? I get negative 12a. So I don't want to do that. I want to get rid of the negative 7a, because the inverse of a negative 7a is a positive 7a. And whatever I do to one side, I do it to the other. And I want to add that to the other a over there, right? So 5a plus 7a to keep my a's positive. It makes it a lot easier to do that. And now let's work straight down. 5a plus 7a is 12a. Bring down my plus 2. Bring down my equal sign. Bring down my 6. This negative 7a and 7a cancel each other. And now I can work from there. So I got my variable to one side. Now let's get it by itself. So do the inverse of what's being done. I can't touch the 12x that's connected to the a. So I'm going to do the inverse of adding 2, which is subtracting 2. Whatever I do to one side, I do to the other. Bring down my 12a. These cancel. Got my equal sign. And 6 minus 2 is 4. And last thing, we're multiplying by 12 with the a, so the inverse is divide by 12. Whatever I do to one side, I do to the other. 12's cancel. Bring down my a. Bring down my equal sign. 4 divided by 12. Once again, it's a fraction. Let's just simplify it. 4/12 simplifies into 1/3, right? I divide each by 4. So a equals 1/3. Looking at number 3. Looking at number 3. I'm going to get rid of this answer just so we can see it. It looks kind of sloppy in here. So left side and right side, they're both simplified. But if I look, here I have a 1/4 x, and here I have an x over 2. They look kind of different. Can I get them both to a fraction times x? Can I do something to this guy right here? I can. Okay, if I think about it, x over 2, I could really write that as 1/2 x. I could essentially pull my x out of here, and I have a 1 up top. And the reason why I can do that, if I think about that, if I have a 1/2 x, it's really 1/2 times x, isn't it? And I could put x over 1. And if I multiplied 1 times x is x, and 2 times 1 is 2. So it's the same thing, right? These two guys are the same thing. So I can just pull that x out of there. I'm going to rewrite this. I'm going to pull that x out, and it's really 1/2. I just replace that with a 1 up top. Because now when I get my variable to one side, I can either move the 1/2 x or the 1/4 x. The 1/4 x is smaller, so I'm going to subtract that from both sides. So to get rid of the 1/4 x on the right side, I subtract a 1/4 x. That's the inverse, right? Whatever I do to one side, I do to the other. And 1/2 minus 1/4 ends up with 1/4, right? I could get a common denominator to go through that or use a calculator. Hopefully some of us can do that mentally. So that's 1/4 x plus 1 equals, those cancel, -6. Don't forget to bring that negative sign down with it. It's a -6. And now we do the inverse of what's being done. So we subtract 1, and we're left with 1/4 x equals -7, right? -6 and -1 give me -7. And the inverse of multiplying by 1/4 is dividing by 1/4, but we want to multiply by the reciprocal instead, right? Just like we learned the other day. So we're going to multiply by 4 over 1, or we're really multiplying by 4. So these cancel, and x equals -7 times 4, -28. So that one took a little bit of thinking, right? I had to take that step by pulling that x out of that x over 2. Now let's start doing some where we have to simplify. So now if I look at the left side and the right side here, I have to distribute before I can do anything, can't I? I could follow some other algebra rules, but let's just stick to distributing right now, which will make things easier for us. So I got to let's deal with the left side first. 7 times n and 7 times -1. So 7 times n and 7 times -1 is -7. Bring my equal sign down. Now let's deal with the right side. -2 times 3 is -6. And -2 times n is -2n. Now they're both simplified. So I can get my variable to one side. Usually you want to move the variables that are negative because the inverse is a positive 2n. So to get rid of that -2n, I add 2n. Whatever I do to one side, I do to the other. Got to do it right below the variable with the n, or the term with the n. So 7n plus 2n is 9n. Bring my -7 down, bring my equal sign down, bring my -6 down. That's gone. And now get your variable by itself. Do the inverse. Inverse of -7 is +7. Whatever you do to one side, do to the other. Bring my 9n down. These are gone. Bring my equal sign down. And -6 plus 7 is a positive 1. And 9n, so 9 times n, the inverse is divide by 9. If I do to one side, do to the other, that's gone. Well, n equals 1/9. Just leave it as 1/9. Don't write that as a repeating decimal. And that's why we like to leave it as a fraction. Okay, so I don't have a bunch of repeating decimals or having to round. It's more exact. Number 2, same thing. Same thing. Let's go ahead and distribute, right, to simplify. So 1/3 of 18 is 6, right? I'm really just dividing by 3 here. So 1/3 of 18 is 6. And 1/3 of 12c, well, 1/3 of 12 divided by 3 is 4. So 4c equals 6 times 2c, which is 12c, and 6 times -7, which is -42. And now let's get our variable to one side. Preferably move the 4c, because we want to keep our c positive. So we subtract 4c. Whatever we do to one side, we do to the other. Bring our stuff down. 6, that's gone. Bring our equal sign. 12 minus 4 is 8c. And bring my -42 down. And now let's get our variable by itself. So the inverse of subtracting 42 is adding 42, right? Always work on the side of the variable. So I add 42 to the other side. So 48 equals 8c. And the inverse of multiplying by 8 is dividing by 8. Whatever I do to one side, I do to the other. So c equals 6. C equals 6. Okay, we got a couple cases here that we got to look at. So I'm going to quickly run through this. I got to simplify it, so I'm going to quickly do this. 8 times 5m is 40m. 8 times -2 is -16 equals 10 times 32, which is 320, and 10 times 4m, which is plus 40m. If I notice, I got a 40m on each side. So when I get my variable to one side, when I subtract 40m, let's take a look at what happens here. Well, that's gone. I bring my -16 down. Equals sign down. Bring my 320 down. These are gone. So my variable's gone. Well, and if I take a look at this, negative 16 equals 320. Do those equal each other? No, those do not equal each other. So do you think there's any number I can put in for m to make this statement equal, to make this equation true? No, there's absolutely nothing I can put in for m to make that true. M doesn't equal anything. So we say there is no solution. There is no solution. Same thing with number 2. We're going to get a little something different though. So I'm going to go ahead and distribute quick. So 4d, 4 times 20 is plus 80. Bring my equal sign down. A fifth of 20, or 20 divided by 5 is 4d. And a fifth of 400 is 80. Well, now if I look at it, I have the exact same thing on both sides. So when I subtract my 4d on both sides to get the variable by itself, they cancel and I bring my 80s down. Well, 80 equals 80. This makes sense, doesn't it? This actually makes sense. So what's going to happen? I could put anything in for d, and this equation would be equal to each other. The statement, or the equation would be true. I could put anything in there. Okay? So we say that every solution works. I can put any number, any decimal, any negative number. So we say all real numbers. All real numbers. Right? Every solution works. Or you could put the property that is. We call that the identity property, where every single number works for that variable. Either way, I'm okay either way. Lastly, you might have to use some knowledge to set up an equation before you solve. So for example, here it says find the value of x so that the figures have the same perimeter. Well, here's our key, same perimeter. So if this is the perimeter of the first shape and this is the perimeter of the second shape, I want to set those two guys equal, right? They have the same perimeter. Well, I need to know what the formula is for a perimeter, or how to find the perimeter of a rectangle. So if I think about perimeter, I have 2 widths and 2 lengths, and we add them all up, right? So 2 times the width plus 2 times the length. We just add them all up. Or width plus length, same thing. And I'm going to set both these perimeters equal. So this perimeter for this first shape, if you think I got an x for the width, so 2 times the width plus 2 times the length. I'm going to put that in parentheses so we can see it. So 2 times the width plus 2 times the length, that's the perimeter of that one. I look at the perimeter of this other one. Same thing, 2 times the width, so 2 times x, 2 times the width, and 2 times the length, so plus 2 times, I have 2 of those lengths, right? I have 2 of these, 2x plus 2, I got that other side 2 over here. So that's why I'm going to take 2 of them, and I'm going to set them equal to each other. So I'm going to set these two guys equal. So here's my equation I'm going to solve. 2w plus, well, 2 times 6 is 12. Oh, actually, that's an x, isn't it? Screw that one up. So 2x. That's an x. Equals 2x, and we'll simplify that. I'm going to distribute this 2 right away. So 2 times 2x is 4x, and 2 times 2 is plus 4. So I got to set those two guys equal. Well, now I got to simplify the right side here. I can combine my 2x and my 4x to get a 6x plus 4. And now it's just the same thing, getting our variable to one side. So it's basically coming up with those two equations to set equal. That's the hardest part. And now I get my x to one side, and we bring everything else down. Subtract the 4 from both sides, and divide by 4. I'm going to bring this up and over here so we can see it. 8 equals 4x. So divide by 4 from both sides. So x equals 2. And that's what we're trying to solve, right? Find the value of x. So we're done. So the hardest part is just setting up that equation in the first place. Might have to use perimeter, might have to use area. All right, good luck with solving those equations.